homework number 7, and this is going to be problem 2. And we have this hangar in the new U-Hart High Bay. That's in the new building right there. They built the whole building because of this high bay requirement in this. That's why we have the new building. The history of it. It's kind of weird. It's made of this bent pipe right here with a single cable that's coming through right through there, connected to the wall at D, passing through a frictionless ring at B, and connected to the wall at E. The cable has a tension of 45 newtons. The dimensions are 500 millimeters. Let's see, this one right here. 200 millimeters. Where does that go? Where is that? Right here. Oh, 200 millimeters right here. And AD. Okay, so it's 550 up. This is 400 up from here. This is 600 right here, and this is 300. Okay, so I went X, Y, and Z. That's why I did it in order. And we want to find the angle between these cables, BD and BE. Okay, so we want to find what this angle is, and we want the magnitude of the moment about an axis that goes between A and C. There's quite a bit of stuff going on here. Okay, so but anyway, this is a problem or a similar one that has been asked in other classes, so I don't feel terrible about assigning it here. And so this is going to be spring of 21, and we are ES110, and this is homework 7. This takes a long time to do, these videos. Maybe I should just assign stuff from the book and let everybody cheat. Wouldn't that be nice? Everybody could cheat. You just say, you know what? Why bother learning anything? Well, I'll just cheat off of Chegg. Just cheat off a Chegg. Well, one thing I know the other day is that my dynamics class had an exam and they did not do well, and it really upset me. I want to see every student succeed, and then when I don't succeed, it makes me feel bad. I feel as though I let them down. One thing I can take away from it, though, is that I know that they weren't cheating because no one did well. That is not funny. I'm trying to make myself feel better about it. I take it personally. I own it. What can I say? All right. So here's the connection points right there and right there. And so we have a line that connects through there and through here. Right, so it has the same tension. So it has the same force, but not the same force magnitude. So here's E. Here's the y-axis. Here is D up here. Here is A. Here's the z-axis. And here's X, and here is C. And so if we're going to have distances that we place inside here, ooh, I got all smudgy. Gotta be careful. I need to go wash my got graphite all over it now. It's going to be, now all my work is going to be all messy because my ruler got smudgy. I have other rulers. I've got a secret stash. Let's see. I can go ahead and label these other things. This is going to be X, A, I didn't label B. B. This is Z, BC. I'll label this next to this is YCE. This is X, and this was O. All right, so X EO. A lot of times I go OE. And then this is ZDO. And this is going to be YAD. Could be OD too. Just like this could have been OE, whatever. So given FBD is equal to FBE, which is equal to 45 newtons. Then we have a lot of dimensions. So we have XAB is 500 millimeters, and XEO is 200 millimeters, and then YAD is going to be 550, and then YCE is 400 millimeters, and then ZBC is 600 millimeters, and then ZDO is 300, and I left off that it was millimeters, but I'm pretty sure it was millimeters. And then for our find, we want to have, let's see, A says that we want to have the angle between BD and BE, and then B, I should move that over to the left some. We want to find MAC, right? A moment about an axis that is drawn right here. So there's a lot of position vectors and stuff to go through here. So let's get started. I'll move the stupid keyboard over. All right. So I think I want to find, one of the first things I want to do is find the position vector of D with respect to B. And that is going to be in the X direction, right? It's just going to be XAB, and it's going to be in the negative 500 I. And then upwards, it's going to be positive YAD, right? 550. And then in the Z direction, it's going to be BC minus this right here. So it's going to be, I can do that in my head. And it's going to be in the minus direction, right? Because it's going in the negative Z direction. So it's a negative 300 because we took 600 and that minus that. So we could find what the magnitude of that is going to be by taking the square root of all those. 500 squared, 550 squared, 300 squared. So 500 squared, 550 squared, and 300 squared. Square root, we have 801.6. 801.6. And these are millimeters, right? Should have written millimeters here too. Right in there. Okay, do we want to get the direction cosines? No, what we could do is we get the force on here, right? So let's get the force vector of BD right here. And we're going to need it. That's why we're doing it. Okay. We could also, if we only wanted part A right here, we could skip what we're doing right here and then just get this next vector right here and do the same thing, and then we could find the angle between them like we'll do in a second. So we'll use that. But this next step we're doing because we need to get the moment, so we need to find the force anyway. So we take that 45, multiply it by the minus 500, divide it by the 801.6. I'll put the I next to it. And then we get the 45, and we have 550, and the 801.6 J. And then we have the 45 and a negative 300, and the 801.6 K. So we can do all of those. 45, 500 times, I'll divide and then there, and so we're going to have a negative 28? Yes, negative 28.07. Yeah, okay. We're just breaking the 45 apart into little parts. So that's when I first looked at that. I was like, what? It should be a larger number. No, it's going to be a smaller number. Okay. And then I'm going to do the same thing here. I'm going to take 45, multiply by 550, and it should be a positive 30.88 J. And then lastly, we take a 45 and times 300, and I get a negative 16.84 K. And these are newtons. And I didn't fit it into the margin onto this thing. Okay, let's do the thing for the other one. I know, this is a lot of work. So RE with respect to B. So now in the X direction, we are going negative still, but we're going to have this minus that right there, right? So it's going to be that minus that. So it's going to be 300, a minus 300. I. And then in the Y direction, this is only going to be CE. CE, where'd you go? CE right there, 400. And then in the Z direction, it's going to be entirely the BC. 600 and negative. Millimeters. So we want to have now the RE with respect to, that looks like a R, that's a B. B. Find the magnitude of it. I'm not going to be able to fit everything in there. I'm trying to squish too much. The only reason why I put my face on here is I'm thinking that maybe it doesn't seem as like this magic voice talking to you. That you might, I don't know. I didn't always do this. I think it's kind of weird, but maybe. I don't know. I don't know the right answer for what the right thing to do is always. Okay, so now I'm going to turn this force. It's the same magnitude. It's the same 45, but now it's going to be distributed differently. So that's going to be the BE. And it's going to be the 45 times our negative 300 divided by our 8. Nope, not 8. 780. And I might not have left myself enough room. I should probably start this a little bit lower. Let's see what happens. All right, 781.0 I plus my 45 times my 400 divided by my 781 J, and then my 45 times my negative 600 and our 781, that's going to be K. And I decided to shift it down here. So 300 times 781 divided, and that's negative 17.29 I. And we have 400 times 781. We get a positive 23.05 J. And then we get a 600 times 781 divided, and we get negative 34.57 K newtons. All right. Now, we've collected a lot of things. We might need some other stuff here in a minute. What we need is we're going to need for the moment later on, all right, in here in a second, we need to have the position vector of B with respect to O. All right, so the B with respect to O right there is going to be, in the X direction, it's going to be XAB right there. So that's going to be 500 I, and in the Y direction is going to be 0 because they're on the same plane. And in the Z direction, whoops, come on, where do we go? Come back. We decided to go into the sleep mode here. This problem's taking too long. Is that right? How long is the problem taking? Oh, that's already taking a long time. Yeah, it is a long problem. Okay, 17 minutes already. Boy, did I fall asleep or something? No, guess not. All right, so, and this also in the positive Z direction, because we're going to B from O, so that's BC, right there, 600. Okay. And K. We're going to need that. We're also going to need the vector, and it says it's about a line. I think I want to go from A to C. That kind of makes more sense to me. So we're going from C with respect to A. So that's going to be our C with respect to A. Right, so we're drawing a line that's diagonal there. And in the X direction, that is going to be entirely this right here. So once again, it's 500 I, right? It's going to be on the same plane here, but now in the Z direction right here, it's going to be a negative right there to get from here to right there, right? So that's like the difference between these two, and they're crossing each other, right? When we're going from A to C, so we're going in the positive X direction and the negative Z. And when I go to use this, I'm going to need the lambda of it. So I need to have, and I didn't need that here, but I'm going to need this here. So I'm going to take R, C with respect to A, and I'll just write it. I'm not going to put the 0 in there. So 500 squared and 600 squared, add them together, square root them, we get 781. It's interesting, it's the same distance that's right there. Okay, well, coincidence? Probably. And now I want my lambda C with respect to A. And so that's just going to be my 500 divided by 781 I We're going to have a 0 right here still, and then a negative 600 over my 781. Okay. So our lambda that we get for this thing is 0.6402 I plus 0j plus 600 negative 0.7682 K. So if we want to get the angle between these two, and I'm going to wonder how many of you are going to like protest like how much work this is, because this is a lot of work. Already I've spent 20 minutes on this one problem. Anyway, they're hard problems. Maybe I should have only asked for that. I want you to learn, so okay. The first thing I want to do is I want to find that angle that's between the two things. So what that really is saying is that we're going to say that the so use R D with respect to B dotted with R E with respect to B. Right? So what we're going to use there is we're going to take the magnitudes times each other. Right? So the magnitudes of these are 801.6 and 781 times the cosine of the angle between them, which we don't know. But then we're going to multiply all of the parts by each other. So we get a negative 500 times a negative 300, and then we have a 550 times a 400, and then we have a negative 300 times a negative 600. So we can solve all this and add these all up, multiply these, and divide through, get the inverse cosine. So the inverse cosine, and I will just get these in between numbers right in here. So I'm going to take 500 and 300, and that negative cancels out. And I'll take the 550 and the 400, and then I'll add them together in here. And then I'll take the 300 and the 600, and that negatives cancel out. So there, I get a total of 550,000. And then I want to divide it by 801.6, 781. So those multiplied by each other are 626,000. So we divide that and take the ACOS, and we get a 28.54 degrees. And that's going to be the answer to part A. So we didn't have to do all those other force things as part to get that part. Now we're going to do the force things. And I'm going to do this all in one step this time. We didn't in the previous one. So we're going to say that MAC is going to be equal to this CA dotted with F. Well, oh shoot, we can't do it all in one step. We have to do. You're going to hate me. All right, so we're going to need the moment. Are you guys going to be able to do this problem? I think so. Let's take the moment about O. We'll take the moment about O first. The moment about O is going to be R B with respect to O crossed with F BD plus R B with respect to O crossed with F, B, E. I'm going to take a new piece of paper because it ain't going to fit down below. Anyway, and it's making me feel all claustrophobic. I've been trying to shove all that stuff into one page for no apparent reason. There's a lot of freedom in having a blank sheet of paper. And freedom is just another word for nothing left to lose. That's not true. I think that song was actually written by Chris Christopherson, but it was sang by what's her face? Texas. Not Joan Baez, not Joni Mitchell. I don't like the performer. So anyway, she was on the 27 Club, right? She's the one. She died when she was 27. Why can't I remember her name? Maybe it's a good thing. Me and Bobby McGee. Freedom's just another word for nothing left to lose. Me and Bobby McGee, Bobby McGee. All right, so we got I, J, and K, and this RBO that I wrote right up here is going to be my 500, 0, and 600. And the force that I need first is going to be this guy right there. And it's going to be a negative 28.07. That's going to be a 30.88. And this is a negative 16.84. Then we're going to add. I almost made it equals right there. We have to do both of these. I, J, and K. I don't think there's a shortcut around this, not that I know of. We're going to use the same position vector because it's coming to the same spot, but we have a different force on here. So we're going to do both of these. So same position vector. And you're always happy when you get to doing a lot of these that you're like, oh boy, I get a 0, so I don't have to do some stuff. So this is right in there. Get a negative 17.29 and 23.05 and a negative 34.57. Boom. So we got a lot of stuff to write out. Okay. So let's just get to it. Stop complaining about it. So let's start with this guy right here. We got to have a 0 crossed with a 16.89 and subtract out my 600 and the 30.88 I. Not plus. The next one's always minus. Actually, I couldn't do this. I could do that one like there. I could do one at a time. I don't do one at a time. What the hell? So I go minus, and that cross with that, that cross with that. We don't have any zeros in there, and that's a bummer. 500 cross with my negative 16.8. Is that a 4? I think it's a 4. Minus my 600 crossed with my 28.07. Boom. J. All right, so I'm going to come back down over to here. I don't need more of that, do I? Well, I will in a minute. Okay, I'll come back to it when I need it. So let's see. Now we're going to go that cross with that and that cross with that to go to the K. So we get 500 and 30.88 minus, and this is 0. Okay, so we might not even bother to write it out, but we do. Okay, here's K, right? Now we do this next one, right? So we got 0. That's nice to have. Crossed with our negative 34.57. and subtract out 600 times our 23.05, and that's going to be an I. Now this next one is going to be a minus. We're going to remember that, so I'm going to put them over here so I don't forget. And that's going to be that one cross that one, that one cross that one. So 500 crossed with a negative 34.57 minus 600 and minus 17.29. Well, you can't read my own writing right now. 29. I guess it's a 29. It looks like a 9 now when I look at it a little closer. And that's going to be J. Then the last one. Whoosh, it's a lot of calculating. We're going to take that cross that, that cross that. So 500 crossed with my 23.05. And subtract out that cross with that, so that's going to be 0 and our negative 17.29, and that is going to be a K. And these are going to be, what are these, Newton millimeters? Sure, Newton millimeters. MO is going to be calculator time. Be very careful. See our 600. So I like to try to show you my calculator as I do this. Maybe it's a better narration. 600 times 30.88, but make it negative. All right, so, and then we go to the other I. So there's 600 in the 23.05. And that's also negative, so we can subtract out. And so that's going to come out with 32,360. And we could almost like make them into Newton meters right now, or and you know, because it would be 32.32 Newton meters instead of Newton millimeters, because who wants a Newton millimeter? Nobody wants a millimeter. Nobody wants a millimeter. All right, so the next part of this one right here, okay, so there's lots of negatives. There's a negative here, but there's a negative there. So let's make sure we keep track of that and then make it a negative when we're done with it. So I just said the word negative a bunch of times. Negative. Put it right there, and that's negative, right? But we're going to have a 600 times our 28.07. Whoop. 28.07, and we multiply those, right? But that previous one is negative. This one's negative, so we're going to add that together, and we get a positive value, but now it's negative because of that right there, okay? Same thing here with this J. We have a 500 and a 34.57 multiplying by each other, and that's going to be negative. And then here we have a 600 and a 17.29 and multiply them, but that's negative, so it's going to add to that. Yeah. But that turns out to be more than that, so this whole thing is negative here, but then we're going to make it negative again. Boom. And we're going to combine those two things together, so we're just going to add them. So we end up with actually a fairly small 1,511 J. Kind of interesting. There is some amount of rotation that it would attempt to do if you were thinking about it in those terms. And then lastly, we have in the K direction, and fortunately there's some zeros involved. So there's 500 times my 30.88 times, right? And then here we have a 500 times our 23.05, and both of those are positive, so we can add them together. So we get a 26,970 K Newton millimeters. And now, after 35 minutes. We're still not done. You're going to hate your professor. Already too late, buddy. Okay, now what we want to do is we need to do the dot product of this lambda right here against this right here, right? So the moment that we want, right, the whole point of this was about AC. We want to take the lambda C with respect to A right here and dot it with our MO, right? So in order to do that, we just multiply all of the components by each other. So we're going to take that 0.6402 and multiply it by 32,360, and then we're going to add 0, boom, 0. So there's nothing there. Against our negative 1,511, but that didn't matter because it was a 0. And then we did take a negative 0.7682 and multiply it by our 26,970. And MAC, let's see, I'm going to flip those around and put him down. Do I still? Nope, don't have him in there. Okay. So, but I do still have that. So it's a 0.7682 multiplied there. That's a negative right there. And then I need a 32,360 and 0.6402 times that. But I'm going to add it there. Oh my gosh. Are you serious? It comes up to a really small number. 2.359. That's probably just round off error when everything is said and done in this. Look how small that is. Ugh. Well, I might try this in MATLAB, maybe if I got some time, just to see if the round off error would go away. Seems to me that it might, but it was a positive number, right? It was a positive number. Yeah. So that means that it was rotating. That doesn't make a lot of sense that it would rotate in this way right here. I would think that the moment caused by this would tend to rotate. I want to check this out right here. I'm not convinced. I think I might have made a mistake somewhere. But mostly I'm just going to give you credit for having worked all the way through to the end, shown the perseverance in this long, long problem. I didn't think I had made the problem that long. I really didn't. Oh well. Maybe, I don't know, give you bonus points or something for having finished it. Maybe if you tell me that you listened to this all the way to this point right here, I'll give you bonus points for that. Because nobody's going to pay attention to, because we're on like minute 39, like 38:40 right now. It's a really long freaking problem. I'm tired of it. It's like an hour to do this. How long is it going to take you guys? And it's going to see a lot of blank pages, I think. But let's see. And it's almost 9 o'clock at night, and I really should start grading dynamics homework, but I still have to write a homework for this too. Wow. I really need to start doing slow shortcuts. Answer A is going to be theta. I'm just going to write it as a theta. 28.54 degrees. B, MAC is going to be 2.359 Newton millimeters. I didn't turn them into Newton meters because it's just such a small number already. I guess Newton millimeters will work. I don't know. I should just pick problems out of the books. Just pick problems out of the books and let the Chegg people do what the Chegg people are going to do. And then they can fail the exams. And we'll see. Whatever. 2 and 3, and we have ourselves a 40-minute thing. Ta-da!